exhausted.
Yeah.
And he would have missed his free throw, like.
Yeah.
Oh, really?
No, he didn't miss
Yeah,
it.
he didn't miss.
Got it.
I saw that.
That was at the end too, wasn't it, when we already ran like
He's
five?
pretty unfazed by like, he doesn't get mad or frustrated, like he just like is really even, so like.
So he's not Tucker that when he that kicks the ball with the goes up in the rafters and bounces around for a bit.
No,
Did you see that? Yeah, he made us run one time because he kicked the friggin' ball.
Then he did it again.
Because he was mad.
And then he did it again.
And he kicks it and he goes, Jeff? Jeff?
Did we do okay on this homework? We good? It's okay. Any questions, guys?
And then who told you to run?
Jeff. He's like, I want to be like the fun coach, but if you guys, this is like school property, and you guys want to, you can't be kicking it. So, I know you guys don't like Chuck, and I like that.
Like who?
I don't like Chuck because he makes us run.
Who's Chuck?
Riley's dad. He makes us run 24/7.
I mean, it's not bad.
And then we use Evelyn's dad. Yeah, they do. But then we just run all the time. What the heck? That's last year.
It's so painful.
It is.
He came home and he was like, I made a run.
It's freaking annoying. We do this. What?
I heard varsity stuff. Yeah, they do like the 17 back and forth.
Yeah. And then Maddie's like, well, we have to do it. I want to see them run. So you made us do
So
it.
yeah, we have to do it. We made the distance a little bit shorter. Okay, and we do
I think
it.
actually no, it was in this grab section.
We do it in the minute 10. And Jeff made the distance a little bit shorter, and that's like, who would have pulled this? So we have to do it again and longer. You gotta take it.
And we're like, Matt, you couldn't even do this if you tried.
Yeah, exactly.
So this probably is hard.
I'm trying to get
Then he yells up half quarters during the game last night. That one was friggin' deep too. I don't know what he was thinking when he got that one.
A little tile, that's up to you to start.
I used the end of the game, did they win?
No.
It was pretty fun though.
They just run a block.
No.
Well, the clap, we started the clap in the whole period going. That was so
I know.
Was it Kohler doing the
Yeah.
clap though?
Yeah, they
Yeah.
were doing that
It
on the
was
bench.
so
On
toxic.
the bench, they're always just like,
It was just annoying, like I was like,
I wanted to clap for like Matt because he was doing so good, but like if I clap, that's kind of against us.
Yeah.
It felt like they were harassing him for a while, and then like, yeah.
once you start hitting,
Oh, I need to
you
get
stay
it.
sharp. They're
There was one time there where we started.
I know, you're like just like kids. We'll do a fun movie.
They're
We
really
watch a
hot.
movie.
Yeah.
Yeah.
What?
I agree. I watch a movie in every single one of my classes.
I'll give you $5 to watch a movie.
$5 whole dollars.
Well, I got it. That was, it's here.
If I give you my McDonald's gift card,
Give me discounts when I come to
Yeah.
Okay, guys, we'll do this notes. I promise you guys, it's not very long. If you look, it's not like stapled or anything, so it'll be okay.
That means you have to do
There's no big staple package.
So,
My notes for 2 is a staple sheet. They're gonna be mad at me.
so because it's Christmas, we cut out the 2 second halves.
Wait, what part?
Like,
Oh, actually, I did.
these 2 parts.
I did. I
We
did.
don't have
The
to do
first,
it.
no, not that part. Sorry. So it is Christmas. That's not why I cut it off, but we cut. I actually already did that. I think I put it on here already that way. Did I change it here? Yeah. So you can cut out the 2 1 through 5s on the homework. Merry Christmas.
Oh, I thought I was going to do the ones that-
Sorry, the 1 through the first 2. So the 3 through 27s would do. I was looking at them like, why is the homework so long? And then so Christmas here. All right. So, sort of. Okay.
We have to do homework.
I know. Well, that's the thing. So we can get these notes done. I do want to do a fun Kahoot with you guys as a break, but then we'll, you guys will have time to work, and I hope you guys can just get it done, and then you won't have to take math home over the break. So, all right. So, we're gonna talk about trapezoids and kites today. There's no warm up. We'll get going right into notes here. So there's two different types of trapezoids. We're gonna talk about one's just a regular trapezoid, and the other one's called an isosceles trapezoid. And they both have kind of some rules about them, but isosceles is gonna be a little more specific. Does anyone know what a trapezoid is? What specifically makes this a trapezoid?
It has an angle. It's like a triangle and a square.
Triangles, yeah, so if you guys notice it, like if I drew like a straight line here, it's kind of a triangle and a square. There's a property that's really important about a trapezoid compared to some of like a parallelogram or something like that.
Don't you have to take this square, like cut it in half and you have the triangle?
If you were finding the area, yeah, you would do that. Yep. So rather than having two sets of parallel sides, a trapezoid only has one set of parallel sides. So it only has.
You're so cool. I know, I'm beating around the bush.
What? What were you doing?
That's a saying. He's not.
I've never heard that though.
It's kind of an old one, but yeah. Yeah, maybe not the best thing to say. So only has one set of parallel sides. So there's only the one set, so rather than being like a parallelogram where opposite sides are parallel, a trapezoid only has the one set. Now there's some like books or geometry people that would argue that a parallelogram is just a more special type. I would argue trapezoid should only have one set of parallel sides. And that's really it kind of for a trapezoid. There's not a lot else other than, since it's a trapezoid, since there's parallel sides, these two angles should still add to 180. Same thing over here, but they're not necessarily equal. So I'm going to call this one like M and N. So X plus Y equals 180. M plus N equals 180. So those consecutive angles are supplementary. So the two angles that are grab my notes from last year, just make sure I don't miss anything. Oh, I have it here. And with trapezoid, we'll call the two sides that are parallel the bases. The other two sides are called legs. Now an isosceles trapezoid, hopefully the word isosceles makes you think about a triangle. Isosceles has two equal sides, or a pair of equal sides. Isosceles trapezoid has that as well. So it takes a trapezoid, and now the legs are going to be congruent. So it has a set of congruent legs. So the legs are going to be congruent on our trapezoid. The bases are still parallel. Now, just like in an isosceles triangle, there's also angles that are equal. In isosceles trapezoid, the base angles are going to be equal. So this, and then those two would be equal. And the last thing that's true about just an isosceles trapezoid, the other facts I'm going to write are also true of a regular trapezoid, so I probably should change these notes a little bit, is the diagonals are congruent. trapezoid these rules. So if I draw those diagonals in, those should be congruent. So the next two bullet points, or I guess, I'll just do the one more bullet point. This next one is for all trapezoids. So the consecutive interior angles are supplementary. We kind of wrote that up above. So that was like the x plus y equals 180 and the m plus n equals 180. So that's this. Sorry, a little bit disorganized notes there. So our first example here asks us to show that this shape is a trapezoid. So in this drawing, hopefully it kind of looks like a trapezoid, but we want to show that for sure it's a trapezoid. So we want to figure out, how do I know for sure that this has to be a trapezoid? So in order to be a trapezoid, I need to have one set of parallel sides. How do I know lines are parallel if I have a graph? What do I know about parallel lines if I'm using a graph, or parallel lines in general? Slope. What did you say about slope? Did you say something about slope?
Yeah, okay.
The slopes are going to be the same slope. Yep. So parallel lines have the same slope. So if I want to know if these are if this is a trapezoid, I have to check, are any of these lines parallel? Now slope on a graph shouldn't be too bad. I should be able to do rise over run. Can you close up the computer, please? So if we do rise over run, we can check that slope. Which two lines look parallel? So YZ and XW kind of look like they should be parallel, so we're going to check that. So YZ, is it parallel to XW? That's kind of our question there. So we're going to do slope of rise over run. So if I'm going from Y to Z, I would go down 1, 2, 3, and over, down 3 and over 6. If I do X to W, I'd go down 4 and over the 8. Is that the same? Yeah, they're both in negative half. These slopes are the same. So this would be a parallelogram because we have one set of parallel sides. So in a parallelogram, all you have to do is check that one set of parallel sides. That's the only thing that needs to be true. All right, let's look at example 2. Sorry, I'm going to ask you, instead of for M, I'm going to ask you for K, because M's already given to you. Sorry, I'm just writing myself a note. I'm looking for angle K. They tell me angle M is 100. They tell me this is an isosceles trapezoid. Because of the two little marks, so I have the parallel lines and I have the legs being congruent. So what angles have to be the same? J and M have to be the same. So this is kind of turned from what the drawing was up on the top. So J and M should be the same. So if M is 100, J has to be 100 as well. K and L are the same. And how do I know what K and L are? So we should know that they all equal 360 because this is a four-sided shape, guys. So that's one way to do it. Otherwise, there's also something else we know about the angles in here.
They're supplementary.
They're also supplementary. So if this one is 100, L should be what? 80. And then if this is 80, this has to be 80 as well. But also what Luke had said about it equaling 360, that would also work. The fact that we know they'd be equal, we'd already used 200, we'd be left with 160, we could divide that in half. So these are each 80. All right, why don't we finish up trapezoid? So flip to the other side. And then we'll have our break. So a mid-segment is a trapezoid. It's kind of like a median of a trapezoid. So it connects the midpoints of each of the legs. So like kind of like a median of a triangle. Almost if you picture like kind of slicing off the top, right down the middle. There's a formula for this median, and I'm going to call it MN for this mid-segment. And actually, let's call the other sides, I guess maybe we can just call them the bases. It's just going to be 1/2 of the two bases added together. Now this line, just so you guys know, should be parallel. All of these should be parallel. These are our bases. And then this one is called the mid-segment. It's basically going to be the average of those two. So if I gave you that this one is 10, this one's 16, we should be able to find the mid-segment. Go ahead. The one is 10, the other one's 16, we should be able to find the mid-segment. We basically just add them together and divide by 2. And some of you guys are just like, well, that's kind of obvious, that would just be 13. That's all it is. It's just the halfway point between them. So this next one's a little bit tougher. They give us the mid-segment, and they want us to find the other side. They want us to find the other base. So this one requires a little bit of algebra to do this. So they're giving us the answer. So our formula is 1/2 the two bases added together. And they're giving us the mid-segment, which is 30. I know one of the bases, but the other one they just call x. Do we know how to solve something like this?
Multiply by 2.
Yeah, so I would get rid of that fraction first by multiplying by 2. So if I multiply each side by 2, it cancels the 1/2 out. So then I'm left with 60 equals the 1/2's gone, 18.2 plus x. And then I'm easily able to solve this to find out the value of x by subtracting 18.2. We get 41.8 for x then. Alright, so we'll pause here and we'll finish up with kites after, bless you, we'll do a fun Kahoot. Let me just find a good one here for us.